I simply can't believe it.
I just want to say one word to you. Just one word.
Yes, sir.
Are you listening?
Yes, I am.
Plastics.
Exactly how do you mean?
There's a great future in plastics. Think about it. Will you think about it?
Yes, I will.
Enough said. That's a deal.
Plastic pollution is a global environmental issue, and its major aspect is the presence of microplastics in the aquatic ecosystems. Through physical, chemical, and biological processes, large plastic debris fragments can degrade into micro-sized plastic, commonly referred to as microplastics. Microplastics are specific plastic particles with size from 1 nanometer up to 5 millimeters according to the U.S. National Oceanic and Atmospheric Administration and have been detected in all levels of the marine environment. These very small pieces of plastic are defined primary microplastics if they are directly released into the environment as such microfibers, microbeads, nodules, and secondary microplastics if are generated from the degradation of larger plastic products once they enter the environment through natural weathering processes. Microplastic debris pollute all environments and are particularly profuse and dangerous in the marine environment, with adverse impacts on marine biota, biodiversity, as well as human health. Microplastics have been found in the stomachs of many marine organisms, from plankton species to whales. They can also accumulate toxic substances on their surface, therefore represent a potential concentrated source of environmental pollution or act as a vector of toxic pollutants in the food web with some severe health implications. The microplastics concentration in the ocean is exponentially increased in the last few years as a result of increased plastic production, use, and inefficient waste disposal management. For an accurate evaluation of the presence and the effects of microplastics in the marine habitat, it is necessary to use standardized sampling and quantification methods and common units. A number of sampling techniques have been developed and designed to assess the presence of microplastics in the marine matrices. Through reproducible analytical methods with low technology and cost-effective, to improve characterization, identification, and quantification of plastic fragments. The first step is the sampling on the sea surface by Montanet. Start the sampling by Montanet in one straight direction at 4 meters distance from the boat for 30 minutes with a speed of approximately 2 or 3 knots. Raise the Montanet out of the water and rinse the outside of the net with seawater. Remove the cold end and sieve the sample. Rinse the sieve into a glass jar using 70% ethanol and keep refrigerated. The second step is the separation by visual identification using a stereo microscope. Visual sorting under microscope is necessary to separate the microplastic fragments from non-plastic particles. Each plastic piece could be picked up with forceps and placed in graduated dish to be counted, measured, photographed, and classified. Digital photography enhances the morphological parameters and surface of substantial plastic particles to be computed automatically. Electron probe microanalyzer allows a more detailed observation of microplastics morphology and distribution in the sample. Fourier transform infrared spectroscopy offers the possibility of accurate identification of plastic polymer particles according to their characteristic IR spectra.
Siamo riusciti per fortuna in Italia a fine dicembre 2018 a vietare l'utilizzo della microplastica nei cosmetici, ma ovviamente questo non basta, visto l'enorme quantità di microplastica anche industriali che passano, diciamo, dalla depurazione e arrivano nei mari. Bisogna cambiare rotte e quindi cosa dobbiamo fare? Dobbiamo assolutamente evitare di utilizzare il monouso, perché la maggior parte della plastica è quella là, e dobbiamo riutilizzare e ridurre l'esistente, cioè fare in modo che le plastiche che noi utilizziamo abbiano una seconda vita, una terza, una quarta vita, per evitare di produrre nuova plastica. Ogni anno noi produciamo 430 milioni di tonnellate di plastica nel mondo e praticamente non sappiamo più dove metterla.
Now, let's try as true biologists to understand how much plastic is under our feet. We will take 20 liters of seawater and filter it with a 300 micron sieve, the size of the microplastics. After that, we will observe any fragments left in the sieve with the stereo microscope, describing the morphology and counting the quantity present.